So we've all probably written a loop that looks something like this before, like, for I equals 0, I less than the array dot length plus plus I, do something with that element. And this idea is trying to just really express, go through each element and do something. But iterators generalize this concept because not all things are linear and not all things are going to be indexable by some position like 0, 1, 2, or 3, right? We might have our maps which are indexed by their key. We might not know ahead of time what are those keys going to be, but we still need to go through the elements. Or we might have like a tree which branches and we need to still go through all the elements in some order, right? But we also don't know how to index an individual one by its position. If you guys have used Python before, you've definitely used that before, like, for each element in. And iterators kind of allow you to express that idea here inside C++. You can create iterators over your own classes, and you've probably seen some of the iterators that we talked about with like the vector. Normally what an iterator is just going to be a class that keeps a reference to the object that it's iterating over, and it's also going to keep track of what position it's at, however it intends to do that. They also tend to implement a few common operators. These are star, arrow, plus plus, minus minus, equals equals, not equals. And some other iterators might also implement like plus equals or minus equals or plus or minus less than or greater than. It just depends on what you might want to be able to do and what makes sense for that particular container. Some things might only be able to go forward. These would be called forward iterators. For example, like when you read through a file, you go forward and you can't really go back. There's no way of returning. Or if you have a linked list, the linked list is composed of nodes, and each of these nodes has a pointer to the next node in sequence, and they also have a value, 7, 12, 13, 45. So here, once I advance from 7 to 12, I'm at this position. Notice there's no way for me to get back. Right? And if I go from 7 to 13, again, I can't go back. So that'd be an example of a forward iterator. I also only have access at the beginning to the front one. So I can't access just a random position inside there. So some iterators fall into the class of random access iterators. You can access anything inside the container, right? You don't have to go through them one by one. But with an iterator over a linked list, you'd have to go through the elements individually. Some iterators allow you to go forwards and backwards, those we call bidirectional iterators. So for example, when you do your doubly linked list, which is just a linked list where everybody has a pointer to the next thing and a pointer to the previous thing, your iterators will be bidirectional. You have to go forwards and you have to be able to go backwards. Also, your container classes will also generally provide a method called begin to give you an iterator to the beginning of the object, and an iterator called end to let you know that you've reached the end. And generally, when you get that iterator to the end, it's one element beyond the end. So the end iterator is not safe to dereference to access that member. Like the null character? Yeah, kind of like that. Hmm? Are you recording? Hmm? Yeah, I remember to start. So what I want us to do now to practice is I want us to write an iterator for a range, right? You guys have probably worked with range in Python. You have a start, a stop, and a step, and you go through them one by one, or you go through them by step. So this would give you an idea of doing an iterator over something a little bit simple. So file, open recent, range. Also, make sure to be using like Git. It's really useful. So over here, we have our range class. That's a lie. And for our range class, right, we have our start and we have our stop and we have our step. These are the things that we need to memorize. And we also just have a function over here that's going to print things out. And it just says, just prints out our values. I'm also going to modify our constructor here to make it a little bit more user-friendly. So we can have the one that we had before, but we'll make this not default one. We can have a range where we provide both the start and the stop. And we can also have an iterator for the range where we provide just the stop. We'll get rid of these right now too. So here we're just going to call our default constructor, or not our default, our one that has all the arguments to initialize ourselves. So we'll call range with our start being our start, our stop being our stop, and our step should be, you don't give a step, the step defaults to 1. We'll just say 1 there. So this constructor is calling this constructor to initialize it. And then if we just have a stop provided, call the range class again, our start should be, if the start's not provided, it should be 0. Our stop should be our stop. And now we'll call the 2-argument constructor to get that to work. So this constructor will call this constructor, which calls this constructor to actually do the initialization. So for our range iterator class, these would tend to be the set of functions that you would need to implement. A constructors, right? And then we need some functions that allow us to access the members. Over here, we might want to provide, well, for this particular problem, this guy's good enough. So we have our pre and our post increment iterators. You can notice the difference between pre and post is that, again, the operator plus plus accepts an int to make sure that it's the post version. The pre version doesn't take an argument. And we notice that back here in range, we made our range iterator class our friend, so we could have access to the private members because we're going to need to use those. And what we have inside of ourselves is we just have a reference to the range that we're iterating over, and we have what position inside the range that we're at. Does that make sense in terms of what we need to keep track of to implement this iterator? So these guys aren't too complicated as to what they do, but we'll get through the other ones in a moment. So operator star, right? We want to be able to access the value that we're at. So what should we return? What value are we at right now? What's keeping track? Pause, right? So we could just return pause. You're going to find that a lot of the code that we're going to write here is pretty boring, right? It's BOC, boring old code. So operator plus plus, right? We want to go to the next thing, and we're going to return a reference to ourselves. So how do I get to the next thing? Not plus step, right? Our range dot range step. And the reason we're able to access this private member is because we're range's friend. So range is giving us access to the private portions. So just pause plus equals range dot step, and then we return star this. This should be a const range iterator, not a reference. And here should be const 2. Okay, so now we have the post increment version. How do you think we should write this? Right, because if you did like I plus plus, right, and I was currently 10, you'd want the value 10 to be given back, right? Well, we don't have a plus 1, we don't have the operator plus defined. pretty close. But again, we still haven't defined like addition between ourselves and an integer yet at all. So what we could do, which you kind of have the right idea, is we want to create a copy of ourselves first, right? Create a range iterator called, say, copy, which is a copy of ourselves, right? Then it's safe for me to go to the next thing, right? So now I can do plus plus star this, right? Call the pre-increment version. And then I can return the copy. Right? The copy will have the old value, which is what we'll give back, and I'll move on to the new value. Right? And I'll reuse this portion of code up here so that I don't have to rewrite it. Does that make sense? Any questions here on this? Yeah. So what I do first is I create a copy of myself, right? So let's imagine we want to do like I plus plus, right? If I is currently 10. So I make another variable that is a copy of the value 10, right? I then add 1 to myself by calling operator plus plus pre-increment here, right? Who's going to advance me to the next element. But notice the copy, he's a copy, right? He hasn't changed. He's still at the 10. I'm at the 11 now. And then I return back the copy, so whoever called me gets the 10. But I've moved on to the 11. Or is line 23 the one that's getting you? If you want a little bit more clarity, what this is saying is it's saying this arrow operator plus plus. I'm calling this method up here. All right, notice it has the same signature. This is another way of saying the exact same thing. But you're more than welcome to use whatever version you feel comfortable with. Are there any questions here? I like the 23 version better. That's just me. So if we wanted to be able to do operator minus minus, well, what do you think we'd do? Minus equals the step. And so like a lot of this code, you're like, oh man, this is like really boring code. And if we wanted to do the post increment version of operator minus minus, well, let's steal the same idea, but do minus minus. Then let's say we wanted to do operator plus equals. Right, I want to move some amount. And right now we're going to do it a very, very bad way, but a more generalized way, and then we'll also talk about the fast way of doing it. So here's the bad way of doing it. For I equals 0, I less than the right-hand side. I just call my plus plus in a loop. Right? I want to, go forward 3 things. I call plus plus 3 times. Right? I want to go forward 5 things, call plus plus 5 times. And that's all I'm doing here. And then eventually, again, I return a reference back to ourselves. This looks terrible, wouldn't you agree? Like, there has to be a better way of doing it. In this particular problem, there is. But if we wanted to be able to find a plus equals operator on something like a linked list, the only way to get to 3 elements beyond is by going through the ones that are in between. Right? So I would actually have to do operator plus plus in a loop to get me to move to the element that I wanted to be at. Move forward 5 from where I'm at, or 2 from where I'm at. Does that make sense? So what would be, yeah. Well, I mean, like for a linked list, there is no better way of implementing it than this, right? It's what you have to do. For this particular problem, though, we could do faster. So what would be faster? But we have it as we have a reference to the range, and we can ask the range for what its step is. Well, yeah, this is moving the pause, right? Notice that the pause is increasing by range.step. Not quite.
The parameters.
This, yes, the parameter is the number of steps you want to move forward.
Pause.
Right, this would be like the fast way of doing it, right? You multiply the right-hand side by what your step is, and then you add that result to yourself. So this guy up here is the slow but generic way. Of doing it, right? And so later on when we talk about inheritance next week, you might provide like a default like iterator class. And what it does by default for operator plus equals is that it calls plus plus a whole bunch of times. Is there any questions here? Okay, and so you can imagine that we could define many similar functions for the minus equals and the plus, right? This guy over here, he's not our friend, but we'll talk about operator plus for a second. So this is operator plus. He is our friend, so he has access to our private parts, but he doesn't have access. Yeah, he has access to our private parts at this point in time. So again, this guy right here, there's a really nice trick that you can do to make this happen. We're doing on operator plus, given you already have an operator plus equals. I can make a range iterator called copy of myself, right? And then, well, I can say, hey, my copy plus equals the right-hand side. And then I can return the copy. Hey, nice. Oh, left-hand side. Make a copy of the left-hand side, right? Add the right-hand side to the copy with the plus equals, and then return the copy. So whenever you're writing like your plus operators, they should look like this for the most part, right? Reuse the plus equals you've already written so you don't have to keep repeating that code. Any questions here? So we will skip these guys for right now because you're not going to learn anything from them. And then let's talk about operator bool. So operator bool should return true if we are at a valid position in the range, right? We're still good to dereference. We're still good to access our value. So what should we do to return if we're still good or not? What makes sense? Right, we have to be in between our range. One of the things, though, that makes this a little bit more complicated is our steps can be negative something, right? So with a positive step, like maybe I want to go from 5 to 10 by 2, right? I need to be greater than 5, right? But, or greater than or equal to 5, but less than 10 to be valid. But this is start. But if I wanted to go from 10 to 5 by -1, right, I have to be greater than the stop and less than or equal to step. So we have to put a little couple of condition here based on our step being positive or not to make this happen. Oops. So if range step is greater than or equal to 0, what should we return? Well, pause has to be greater than or equal to the range's start, and pause has to be less than the range's stop. Yeah. Say it again. Well, I mean, like if it's 0, hopefully, this still holds true, right? Else return pause has to be less than or equal to range start, and pause has to be greater than range top. And so this is the function that converts us of type range iterator to bool. So if we static cast a range iterator to a bool, this is the function that will be called to make that happen. Or if we ever need to be implicitly cast into a bool, like if I say if my iterator, I will be cast to a bool here, and this is the function that will be used to generate that boolean value. Does that make sense? Any questions here? So operator not. So this would be the opposite of when we're good. So what should we do? Well, yeah, so like return not static cast to a bool ourselves. Operator equals equals. So for two iterators to be the same, what needs to hold true? But an iterator doesn't have a start, stop, and step. Right? An iterator has a range that it iterates over. An iterator has a position. That range that an iterator iterates over has a start, stop, and step. So one of the things that needs to hold true probably is that we need to be iterating over the same range, right? If you create like an iterator over range 1 and an iterator over range 2, should those two iterators ever be the same? Probably not. They shouldn't ever be the same if they're over different ranges, even if those ranges happen to have the exact same parameters. Like the reason for thinking about this is like if your class supported functions like insert or erase to remove elements, right? For example, vector, right? I might have two vectors that have the exact same elements, right? I could create an iterator over vector 1 and an iterator over vector 2. Should I ever be able to use the iterator in vector 2 to like just to remove an element from vector 1? No, right? And I shouldn't ever be able to use like an iterator from vector 1 to like insert an element into vector 2. Therefore, even if they happen to both be pointing to the same values or like at the same positions in each iterator or in each range or in each vector, they shouldn't be considered to be the same. So they need to be iterators over the same or different objects. And they probably also have to the same, they need to be iterators over the same object, and they probably have to have the same position. So this will lead to some complications though in a second if we say things that way, but we'll put it there. So return, right? My range is equal to the right-hand side's range. Yeah, I know. And my pause is equal to your pause. Operator not equals. Yeah, return not of equals. Right? I don't like rewriting code. And the iterators are like really like, again, boring old pieces of code. They have to be written to get things working. You know, less than, greater than, or equal to, right? We could define these fairly easily, but we'll leave them out for right now. No, you don't have to define all of the operators. Basically, the ones that you would absolutely need to define to kind of like have like to be at least a basic iterator would be operator dereference, operator plus plus, operator equals, operator not equals, operator bool. Those would be the ones that you'd have to define for most contexts for it to be able to work. And that'd be like a forward iterator. Yeah, I mean, it depends like what you want to support, right? You wouldn't actually support less than or greater than or equal to if you didn't want to. And then finally, we're gonna go pop back to range and that we've finished our class. So here we're gonna provide two functions, begin and end. If you also want to be able to do that cool for each loop, like for element in some container, the functions you have to provide are called begin and end, and they have to return some iterator-like object. And iterator-like means it supports equals equals, not equals, plus equals, or plus plus, prefix plus plus. Those are the only three things it needs to support. So prefix increment, equality, and inequality. So operator begin. So we want to return a range iterator. We want to return a range iterator over who? Ourselves, right? Because, you know, if I ask a vector for its beginning iterator, I want an iterator over that vector, right? So if somebody has asked me for a an iterator over me, I'm going to return an iterator over myself, right? And if you look back at the constructor for a range iterator, if we don't give it a position to where to start at, it will start at our start automatically. And then for end, we need to return an iterator to one past the end, whatever that means in your particular context. So again, we want to return an iterator over ourselves, and what should we say is its stopping value? Like what value should we have it initialized to that's one past the end? Which, how do we know? How are we going to figure out what are the end of our ranges? Yeah, it's range stop, right? Because you shouldn't actually get to range stop. And this would be our end function here. With this, though, we'll end up with some problems if we have things like this guy right here. So notice the values that we would construct when going over this range. The top one, what would the values be that you would get over this range if you get 5, 7, 9, right? And if you think about how our iterator classes works, after we plus class 9, we would go to 11, right? When we iterate through things, we try to say like, you know, for iterator equals begin, iterator has not equaled the end, you know, plus plus. So when we set our end iterator, we set our end iterator to be pointing to, or to have the value of the stop, 10, right? We just, you know, we just said that our range iterator for end is range stop, or is range stop. But here it's 11. This is the value that we reached. Are these things the same? No, and so we would have this infinite loop where we kept going, right? So we have a couple of fixes that we happen. You guys have any ideas as to change? Yeah, range stop is an integer. Yeah. Make it equal to range stop. Right? So one way that we could resolve this problem is in our plus plus operator, if we go beyond range stop, we can make ourselves equal to range stop. But again, it can't always be strictly greater than, because it depends on the step, whether it's positive or negative, right? If I have a negative step and I go less than my stop, then I need to become my stop. If I'm positive, if my step is positive and I go greater than my stop, then I need to go back to my stop. Another way that we could modify this is inside of our equals equals operator. And we can make conditions based on whether the iterators are good or not, right? Like if they're both bad, well, then they're the same, right? If they're both equal, well, then it matters if their pauses are the same, right? Then otherwise, right, if one's bad and one's good, then we wouldn't use it. So we'll go for that method now just so that we can see it. And this is where I said we're going to need to make some changes. So the first thing that I need to see is, are both of these guys valid? So bool left-hand side valid is equal to static cast to a bool me. Bool right-hand side valid. Well, it's the right-hand side. The first thing I need to check again is if we're over the same range. So if we're not over the same range, are we going to be equal? So we can return false. Else if oh my goodness. I'm back here. Else if the left-hand side is valid and the right-hand side is valid, right? They're both in bounds. What should we do? What would make them equal if they're both valid? Right? If you're both in bounds and their positions have to be equal. Right? If they're both over the same iterator, because we got past the first if statement, and they're both in bounds, they need to be at the same position to be equal. Otherwise, they are only going to be the same if they're both not valid. Right? Because if one of them was valid, the other one's invalid, will return false. Only if they're both invalid, and we don't care how far out of bounds you are, will you be considered to be the same. Any questions? Be good here. Does this make sense? Okay. So over here in main, this doesn't exist anymore, so not equals. Not equals. And let's try running it. Hey, it ran. And so you can see here, we're doing it with like the iterator strategy where we're explicitly saying, you know, begin and end. And because we provided a begin and an end function, we can just say, you know, for auto or for const auto val and get the values as we run through them. And then again, this is with like a negative step up here that would have gone out of bounds in an infinite loop if we hadn't fixed our equals equals operator. Go through it with an iterator version. And then go through it again with the for each version. Yeah. This is basically saying like for each value in R2. So with, you know, for Python, you would say like for element in iterable. Okay, well, but you're missing out. What this is basically saying is this will be an instance of an element inside of R2, I guess. R2 being our range up here. And basically what actually happens here is this, if you're interested. When we have that for range declaration in range expression, it gets converted to this. Which, there's a lot of stuff here, but basically this for loop right here gets converted to this for loop up here. Right? You start at the beginning, you go until you reach the end, you go to the next element, and then value is dereferenced iterator, whatever it happens to be. Auto over here means I'm going to need a copy of the value. If I want a reference to the value, auto reference. If I want a const copy, const auto. If I want a const reference, const auto reference. And if you know what the type is, you don't have to say auto here, but it's just generally annoying to have to write the type and remember what it is. So I always just use auto. This is like one of the places I always use auto at. Any questions on iterators? Because your next homework is on iterators. Yeah. Sure. So a range, right, returns a begin and an end, right? And those are the return type is range iterator over here, right? These guys just make a new instance of a range iterator over myself. This one starts at the beginning. This one starts at the end for the stop. The range iterator holds a position, keeping track of where it's at within the range. And it also holds a reference over that range, which it promises not to modify. Sometimes, though, you might want to be able to modify the object. It depends. The other thing is the thing that I showed you in class, which I want to run over one more time. So remember how we built our string class guy, right, the other time? Right, where we had our vector of values. So what I provided was I provided iterators over him. And he has a const iterator and a non-const iterator. And he also has a cBegin and a cEnd, which always give const iterators. Which of these functions gets called? The non-const or the non-const depends on the context of the object. So if I have a const string class and I call begin, I'll get back a const iterator. If I have a non-const version of my class and I call begin, I'll get a non-const iterator. And I've also done some type defs over here that says, hey, what type of my iterator do I want? The const version or the non-const version? Yeah. I would choose the const version if I don't want to change anything that's in there. If I'm planning on changing things, I want to have the non-const version. Yeah, it's all a problem. Like, do I want to change what's in my vector? Non-const version. Do I want to not change what's in my vector and just read the values that are there? Const version. So if we skip over the fun typing stuff here for a moment, what do you think operators? So things that we have as part of ourselves, we have a position, which element in the string that am I at, and then I have a reference to the string so that I can actually get the value that's there. So what do you think operator star should do? Not a trick question. Well, it should get the element at that position. Oh, well, it's not letting me go to it. And if you look down here, hey, look at that. What do? We return the element at that position, right? What do you think operator plus plus should do? Go to the next one, right? So we should just increment, pause, woo, right? And that's all we do. And then this guy for the post version is, again, exactly what we did for the range class. Well, what do you think operator bool should do? Again, are we valid? To be able to dereference this iterator, right? Where do I have to be at inside the string? Between the beginning and the end, right? I have to be greater than or equal to 0 and less than the size. Greater than 0 and less than the size. Right? Again, operator not is the same thing. We just static cast ourselves and then negate. Operator equals is pretty much the exact same logic that you just saw, right? We get the left-hand side valid, get the right-hand side valid. Hey, if we're not iterators over the same string, we return false, right? We're done. Otherwise, if they're both valid, we gotta be at the same position. Otherwise, both of things have to be invalid. And so this is like an iterator over an actual container, right? This is an iterator over the string, and it will let you go through the individual elements and modify them. The crazy stuff with this problem is with the type traits and having them be Because this version right now, because of the templating, allows me to both create a const and a non-const version without having to write any additional code. So you can see back here, when I use my using statements, right, I say my const iterator is equal to the string class generic iterator where it should be const, and the non-const one is where it should not be const, false. But this part is probably the confusing stuff. We got 9 minutes, so you should ask. Probably especially, either have two questions. You either have a question about what the hell does this mean, or you have a question about what the hell does this mean? Right?
Yes.
Right? So using is used to create a type def, a type alias, right? It says this is another name for this, right? So another name for value type is char. Make sense? Over here with the conditional, we evaluate this parameter. If this parameter is true, this entire expression here simplifies down to const char reference. So if this template parameter should be const is true, our value reference type is going to be a const char reference. But if should be const parameter type is false, our value reference type is a char reference. Does anybody need me to say that again? Or again, have any questions on line 33? Because that's the one that shows up a whole bunch. So the question is, how is this different from the question mark, the ternary operator in C? It has to do with when this is evaluated. The question mark operator is evaluated at runtime, right? That's when we do the comparison. This is evaluated at compile time, when we're actually creating the code. So here, again, like if I pass in like true or false, I'm creating different code at compile time. Any other questions? Yeah. We defined should be const up here as the name of our template parameter. Remember how before we were doing templates like bool type name t, right? And t was the name of our type. Here we have a template parameter. Its type is bool, and its name is not t. It could be t, but we called it should be const to give it a little bit more meaning. Any other questions? Yeah. The question mark, the ternary operator, yes, does exist in C++. Anything else? So these pieces of code right here are figuring out whether we want, to be like using const references or non-const references, const pointers or non-const pointers, based on what we're trying to create. So you can see that I define these types over here and then I use them later on. So here for my constructor, right? If I'm trying to create a constructor for a const iterator, right, my type needs to be const reference to a string class, right? But if the type that I'm trying to create is a non-const iterator, I need to be able to modify the elements. Well, I need just a string class reference. And so again, depending on the value of should be const, this type over here is either going to be const string class reference or non-const string class reference, to allow me to get the appropriate effect and generate the right code. Well, actually, what I'm trying to create is two different classes here, a const version and a non-const version. It's just that most of their code is identical to each other, except like one should accept const references and one should accept non-const references. And so this prevents me from having to like have two separate files where I've literally have copy and pasted like the exact same code, and the only difference is one has const and one doesn't. Yeah, it's handling like one of the type parameters that we could be switching between. So again, like here again, here's another string class iterator, and it's going to take the appropriate string class reference, either const or non-const, depending on should be const. Both of our operators provide a const version of the access. So the non-const and non-const iterators will both provide a const access method. which is fine, right? But here, this guy is enable if, and basically this code right here is only going to be created if the condition here holds true. If the condition here holds true, this entire expression evaluates to this type. If this expression does not hold true, the code does not get created, right? So the only one that should have a non-const iterator or a non-const dereference is the non-const iterator, right? And so again, this is the non-const version because we will be returning a char reference, right? A non-const reference, which will allow you to modify things. But I only want to create this function if I should not be const. And you might ask, well, why do I have like this underscore should be const? Why didn't I just use regular should be const here? That's what I tried and it didn't work. So apparently this utilizes something in C++ templating called substitution failure is not an error. And so what that means is if the template can't correctly substitute in the types, it won't be a failure. It'll just discard that creation. And so here, if it fails to substitute in the type when it's trying to do this template here, it won't create it. And so it just throws it away. So for non-const versions, the substitution will fail and the value won't be generated. If you just do should be const, you'll get a compiler error if you try to generate the const version. Probably be like, hey, you said that that's what you wanted to not do. And it would fail on generating the code. Yeah. So there are two different ways that templates are used. One is for the typing, which is what we talked about earlier. The other thing is for something called template metaprogramming, which is what we're doing here. The template metaprogramming is all about like getting the compiler to write code for you by using the template features that are there. So this wasn't necessarily an intended feature. It's something people kind of discovered that they could do, and so then they exploited it to help them write less code. So your question is like, what is the difference between using a template and then also the using keyword? So the using keyword, right, just creates an alias for the type. The template parameter means I can create different versions of this class or this function for different types, right? If you think about we had a max function, I can have a max of 2 integers. I can have a max of 2 strings, a max of 2 doubles, a max of 2 pairs, or whatever your type happens to be defined as, right? Those are each different functions, right? They're not different names for the same function, right? Which is what using would do.
Types.
So you're correct with the using. Using allows you to just give another name, an alias to that, right? You know, gosh, like you might have like Evel Knievel might be an alias for somebody, or I can't think of anybody's good aliases right now. Or maybe like an alias for Bruce Wayne is Batman, right? It's just another name for the same person. With the typing, it's not funneling it down to one type. It's in some ways abstracting away the type in terms of what matters. But what actually happens is when you instantiate instances of that template, it creates new versions of that class. So back in our code, when we said like I want a vector of attacks, it created a whole new vector class of just attacks, right? It rewrote all that code. Or when we said we wanted a vector of Pokemon, it created a new vector type of Pokemon vector that had all that code rewritten, and the compiler had to write it. So templates, like expanding the templates, can take a while, especially if you're doing the template metaprogramming. You're correct. We are giving this bool the name should be const, and we're using it again for the template metaprogramming to determine if we want to generate code, for example, here on line 50. And we're also using the template parameter over here to help us pick which of these types do we actually want to be using. Right? Do I want to use a const char reference, or do I want to use a char reference? Well, that depends on whether I should be const or not. And again, if like this is confusing, because this is very advanced use of templates, and for your homework, you can create two separate classes, a const iterator and a non-const iterator. You can copy and paste code between them, and then just change all the names, right? And change all the constants to be correct. So it pretty close. It's if this parameter is const or not, which code should I create, right?
But you have to pre-write all the code you want.
Yeah, it'll write for me, right? And when I'm getting it to write for me is actually here. Hey, I want the true version. And great, it wrote all the code for the true version. Then I'm like, oh, I want the code for the false version, please. And I wrote the code for the false version.
And if I false one variable.
Correct, exactly. I will see you guys all next week.